Okay. So now what we have right here is we have 0 equals 2w squared minus 32w plus 120. We're going to divide all that by 2. Why am I allowed to divide that by 2? They're all divisible by 2, and another way we say that is they're all even. They're the same thing, exactly the same thing. So then I'm going to have 0 equals w squared minus 16w plus 60. Okay? So for this one, we have w minus 10, w minus 6. Because negative 10 times negative 6 gives us positive 60. Negative 10 plus negative 6 gives us negative 16. So my width can be 10, or my width can be 6. Okay? So if I start with my width being 10, so if I start right here and I plug in 10 for my width, 60 divided by 10 is what? 6. So this would be 6. If I start with my width as 6, 60 divided by 6 is then 10. Okay? So that's how that works. Yes, that's right. Okay. So here, yes, question. Yes.
It was on the last thing. Sorry.
Yes, here you go.
When you don't have like a coefficient in front of like the w squared up there,
Yes.
that's when you could just go straight to like the negative.
Yes,
Okay.
and it's wonderful.
Yeah.
Like you want to
It's really
get a little excited when there's
Yeah.
no,
Yeah.
Unless it's 4. Like if it's 4,
Yeah, then
you just divide it and
split
you
up.
group it.
Yeah.
So it doesn't matter if there's a coefficient in front of that. That is the challenging ones, when you've got a number in front of your squared and it's 3. That's what's challenging. And that's where you kind of have to do the trial and error, and you got to make sure, and you got to split the number and all that kind of stuff. Because we don't have a coefficient in front of that w squared, or more appropriately said, the coefficient is 1. Okay? That's when you just split it, just like that. Yes, you're absolutely correct. Is it okay for me to go? Yes? Okay. So, my daughter hasn't texted back yet, if anybody's wondering. Number 4. Suppose the length of a certain rectangle is 2 centimeters more than 3 times its width. That's a lot. Like even I don't know what to write down yet. If the area of the rectangle is 56 square centimeters, find its length and width. So, we may not know how to do anything else, but the one thing that we can do is we can draw a rectangle. Okay? So here's my rectangle. Okay? Suppose the length of a certain rectangle is 2 centimeters more than. Now, I know how to do that. I know how to do 2 centimeters more than. How do I do that? It's plus 2. Just plus 2. 2 centimeters more than is plus 2. Then I've got 3 times its width. How do I illustrate 3 times its width? You got it, 3w. So then I've got 3w plus 2. Then what happens is students are like, uh-oh, I don't know what the other side is. I'm stuck. It doesn't tell me. Alicia, it doesn't tell me what the other side is. It does tell you what the other side is. What's the other side? Okay? Suppose the length of a certain rectangle is 2 centimeters more than 3 times its width. So 3 times its width plus 2 is my length. So what is the shorter side? It's my width. Okay? And sometimes students don't make that connection. So if you feel like you don't know what that other side is, honesty here again. Me too. If you don't know what that other side is, and sometimes that happens with a triangle, okay? Very often that unknown side is your W or your X, okay? If the area of the rectangle is 56 square centimeters, so that's going to be 56 is equal to our length times our width, okay? So here I've got 56 equals 3W plus 2 times W. Okay? Now we can solve. Now sometimes students don't put a parentheses around that 3w plus 2, so be sure that you do that. Okay, so now I'm going to have 56 equals 3w squared plus 2w. So I have distributed that w to everything in my binomial. My next step is to subtract my 56. So I'm going to have 0 equals 3w squared plus 2w minus 56. Now, we are not left, like we've got to factor this the hard way. You know, you might get excited because the 2w and the negative 56 are even, but the 3w squared is not even. So that's not going to help. Now, you could divide everything by 3 if everything was divisible by 3, but unfortunately, the 2 isn't. So this is going to be the more challenging way to factor. So let's walk through that to make sure we've got it. Okay? So I do 3 times negative 56, and the reason I do it that way is there's a number in front of the w squared. 3 times negative 56 is negative 168. So my product here is going to be negative 168. My sum is that number right there. That stays right there. Okay? Now, this one is outside the 12 times 12. Now, I've really tried to commit to staying within 12 times 12 on your test. This one is 14 and negative 12, so it is just outside of that. So here, I would take that 2w, and I would split it. I've got 3w squared plus 14w minus 12w minus 56. Okay? So for my first one, the only thing that I can take out is a w. Okay? That's the only thing I can take out. So I've got a w times 3w plus 14. Okay? Do you see how this number right here is negative? Do you see how that number is negative right there? That's an indication that you're going to have to take out a negative value. Okay? 4 goes into both of these. So I'm taking out a negative 4, and you're left with 3w plus 14. So when I factor this, I've got w minus 4 and 3w plus 14. Okay? So I'm going to erase some of this up here. Okay. So w minus 4 equals 0. Then I have 3w plus 14 equals 0. W can be 4. And then we end up with negative 14 over 3. Now, we have to throw this out. Can you tell me why? That is actually not why we throw it out, because we could have a fraction of an inch or a fraction of a yard. But that's good. If it had said something about integers, we would throw it out because it's a fraction. Because it's negative, and we're talking about the length of the width and length of a triangle. So anytime you're talking about distance cannot be negative. So our w has to be 4. So we've got w equals 4. Are we talking about inches? Centimeters. Okay, so we've got 4 centimeters. And if the width is 4 centimeters, what's the length? Excellent. 14 centimeters. Okay? Mark, I think we're going to rectangle or triangles now. Do you want to ask your question?
I was just asking about the consecutive even whole numbers. Does that mean x plus 2 and x plus 4?
Yes.
Okay.
That's what that means.
Okay. Do you mind if I look at the answer sheet for 1 second?
Okay, let me get this one started. Okay?
Well, I mean, I'm already finished. I was just asking.
Okay. well, you can come up here and look. Okay, the length of the three sides of a right triangle are represented by consecutive whole numbers. Find the lengths of the three sides. Now, what happens here is students get confused with the consecutive whole number part. Consecutive whole number part. Okay? The whole numbers means we've got to have positives. Whole numbers means we've got to have positives. Whole numbers also means that we can't have fractions or decimals. We can't have parts. We can't have parts of that. Okay? So, if I start with X and I need the very next number, how do I represent the very next number? Yes. Okay? Then I want the very next number after the X plus 1.
Would it be X plus 2?
It would be X plus 2. Now, some students think about it as X plus 1 plus 1,
Oh, yeah.
which is still X plus 2. But if you need to think about it as X plus 1 plus 1, that's okay. So what we have right here are three consecutive whole numbers. So let's think about 9, 10, and 11. So if X is 9, does X plus 1 equal 10? And X plus 2 equal 11? You want me to say that again?
Yeah.
Okay. Let's think about, I'm just picking three consecutive numbers. 9, 10, and 11. I just want to make sure I've got the right formula.
All right.
Okay.
Thanks for the answer.
Okay, you're welcome. Okay, thank you. Okay, so this is X. So if X is 9, what's X plus 1? What's X plus 2? Good, and is that what I want? I want three consecutive numbers. Good. Okay, now we're going to use the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. A squared plus b squared equals c squared. Okay? So I have x squared plus x plus 1 squared equals x plus 2 squared. Okay? Now, the other thing that students do is they forget to FOIL. X plus 1 and x plus 2, each of those are being squared. So I've got to FOIL those. Okay? So I have x plus 1 squared is x plus 1 times x plus 1. So x squared plus 2x, x squared plus 1x, so I've done x times x and x times 1, then 1 times x, and 1 times 1. So I have x squared plus 2x plus 1. Okay, and that's going to go for this right here. Okay? So I have x squared plus x squared plus 2x plus 1. Okay? Now I'm going to square x plus 2 times x plus 2. Okay? X plus 2 times x plus 2. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. Okay? X squared plus 4x plus 4. And that's going to go for right here. Okay? So I have x squared plus 4x plus 4. Okay, now, what we're going to do now is we've got to set this equal to 0. We have to set this equal to 0. Okay, so I'm going to combine like terms. Do you see I've got 2x squares? Then I've got plus 2x plus 1 equals x squared plus 4x plus 4. Okay, Everything on the right-hand side, I've got to subtract and move it to the left-hand side. So I've got to subtract an x squared from both sides. I have to subtract a 4x from both sides. And I have to subtract a 4 from both sides. Do you see what I did there with the red? Okay. So over here, everything's gone. And what am I left with? 0. 2x squared minus x squared, I'm left with x squared. So that should make us happy. Okay? 2x minus 4x leaves us with negative 2x. 1 minus 4 leaves us with negative 3. Okay? I can factor that. I can factor that to x minus 3 and x plus 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So when I set each one of these equal to 0, okay, I get 3 and I get negative 1. Now we're talking about the length of the side of a triangle. So what does that tell you about the negative 1? I got to throw it out. Okay, so I'm going to start with 3. X is 3. So what's x plus 1? What's x plus 2? Good. So my answer to that is 3, 4, and 5. Okay? Can I go? Yes. Sure.
Because it's not giving you any numbers to start with. Why can't you just pick 3 consecutive numbers? Like, do they have to be 3?
Okay, that's a great question. So let's just try it. Let's try 3 consecutive numbers. What you're saying, though, is that the 3 consecutive numbers that you pick are going to fit into the a squared plus b squared equals c squared. So you're finding 3 consecutive numbers, but you're also saying that they belong to the legs and the hypotenuse of a right triangle. Okay? That's the key. That's the key. So if I picked 2, 3, and 4, okay, I would have to say, okay, a squared plus b squared equals c squared. Okay, so 2 squared plus 3 squared equals 4 squared. So that's 4 plus 9. Does that equal 16? No. Okay, so it doesn't work. Now, let's make sure that ours do. So I've got 3 squared plus 4 squared equals 5 squared. 3 squared is 9. 4 squared is 16. 5 squared is 25.
Would it be wrong to do it that way?
To do it what way?
The way that we just did it, where you plug in numbers into the Pythagorean theorem instead of...
So you just keep plugging until you find it?
Until you find something?
That's fine. That's using the guess and check method.
Yeah.
You know, you'd probably get there on this one. I'm not sure you would on the next one. But it's possible. It's just using the guess and check method. This is a more straightforward method, I guess is what I should say. More straightforward. Okay? But that, I mean, it's definitely a way to think about it.
Yeah.
Okay. Our next one. Suppose that the length of one of the legs of a right triangle is 3 inches more than the length of the other leg. Okay? So here are the legs of the right triangle. Suppose that the length of one of the legs of a right triangle is 3 inches more than the length of the other leg. So I would have x here, and then I would have x plus 3 here. If the length of the hypotenuse is 15 inches, find the length of the 2 legs. Okay, so here's the hypotenuse. It's 15 inches. So I have a squared plus b squared equals c squared. So x plus 3 equals 15 squared. Okay, what do I have to do with the x plus 3? What do I have to do? Yes, I have to FOIL. So I'm going to take x plus 3 and I'm going to multiply it times x plus 3. So I have x times x is x squared. X times 3 is 3x. 3 times x. 3 times 3. So I have x squared plus 6x plus 9. So I am plugging that in for this right here. So I have x squared plus x squared plus 6x plus 9 equals 15 squared. We know what that is. It's 225. I have to set this equal to 0, so I'm going to subtract 225 from both sides. That's what I'm doing next, is I'm subtracting 225 from both sides. So I'm left with 2x squared. I've just gone ahead and combined those. Plus 6x minus 216, because I have subtracted 225 from both sides. And we get very excited. Why are we excited? Even numbers. Okay, so that means I can divide everything by 2. Okay, so I divide everything by 2. I'm left with x squared plus 3x minus 108. Okay, x squared plus 3x minus 108. Okay, this is factoring that I would expect you to know or be able to do. What is it, 12 and 9? Okay, so the 12 is going to be positive, and the 9 is going to be negative. Okay, now, when I have x plus 12 equals 0, what do I end up with? I end up with a negative number. So do I have to throw that out? Yes. So I'm throwing this out. Okay? So x is 9. Okay? The x plus 3 is 12. Now, another way that you can check this to make sure that you're correct is you can do 9 squared plus 12 squared equals 15 squared. 9 times 9 is 81. 12 times 12 is 144. And if you add those two together, you will get 225. So that's another way that you can check it. Okay? Do any of you need to leave for class? If you do, it's okay. Okay. I'm going to go ahead and do the last one. Can I move off this one? Is it okay? Okay. So the next one says the length of the 3 sides of a right triangle are represented by consecutive even. So the first time we did this was we just had consecutive whole numbers. So we did x plus 1, and x plus 2. Here it says consecutive even whole numbers. So if we start with x, what's the next one going to be? X plus 2, and then what's the next one going to be? X plus 4. Perfect. Perfect. Okay, find the lengths of the 3 sides. Okay, so I'm going to have x squared plus x plus 2 squared, we have to FOIL that, equals x plus 4 squared. Okay, so I've got x plus 2 times x plus 2. X times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. . Okay, so that would be 4x plus 4. So that's going for right here. That's what that's going in for. Okay, so I'm going to have x squared plus x squared plus 4x plus 4. Now, I am going to FOIL x plus 4 squared. So I have x plus 4 times x plus 4. I have x times x times 4, 4 times x, and 4 times 4. So I have x squared plus 8x plus 16. And I am plugging that in for this right here. Okay? So I have x squared plus 8x plus 16. Okay, now I've got some like terms. So the first thing that I'm going to do is I'm going to add these like terms. X squared plus x squared. That gives me 2x squared plus 4x plus 4 equals x squared plus 8x plus 16. So now I've got to subtract everything that's on that right-hand side. Okay? So I'm subtracting x squared, then I'm subtracting 8x, then I am subtracting 16. So on this side, I'm going to be left with 0. I have x squared minus 4x minus 12. And fortunately for us, that factors very nicely. What two numbers? What two numbers added together give me negative 4 and multiplied together give me negative 12? 2 and 6. Which one's negative? That is a great question. Okay? Our sum is negative. So the one with the higher absolute value is going to be negative. Okay? So our 6 is going to be negative. So we're going to have x minus 6, and we're going to have x plus 2. Okay? So then I have x minus 6 equals 0. X plus 2 equals 0. So I have x equals 6, and then I have x equals negative 2. I have to throw out this. Why? Because it's negative. Okay? And we're talking about distance of the side of a triangle. So we have to use, it has to be positive. So then I have x is 6, x plus 2 is 8, x plus 4 is 10. And if you did 6 squared plus 8 squared equals 10 squared, it's going to work out. 6 squared is 36. 8 squared is 64. 10 squared is 100. Those are called Pythagorean triplets. Pythagorean triplets. Okay. How we doing?